In this video, I'll provide an overview of addition reactions of alkenes, and I will also explain how to predict products based on regiochemistry and stereochemistry. An alkene has a double bond between two carbon atoms. One is the sigma bond and the other the pi bond. And so when an alkene reacts with a molecule AB, to form the product, what you have to do is to break the pi bond and add groups A and B across the double bonded carbons. Here are some terms we need to know before moving forward. 1. Regiochemistry. Regiochemistry could be influenced by either Markovnikov addition or anti-Markovnikov addition. Second, stereochemistry. Stereochemistry can either be influenced by syn addition and or anti-addition. What exactly is regiochemistry? In a reaction between an alkene and molecule AB, regiochemistry refers to the specific region or position across the double bond of the alkene where groups A and B will be attached. For example, group A could be attached to carbon 1 and group B attached to carbon 2. Or group A could be attached to carbon 2 and group B attached to carbon 1. When should we not bother about regiochemistry? In other words, when is regiochemistry not important? Regiochemistry is not important when adding two identical groups across an unsymmetrical alkane. This alkane is unsymmetrical because you cannot divide it into two equal halves by drawing a line through the double bond. In this case, regiochemistry is irrelevant. This is because since the groups are identical, their positions will not change the final product. For example, if we add these two OH groups across the double bond of this unsymmetrical alkane, it doesn't matter which double bonded carbons the two OH groups are attached to, the product will be the same. Hence, regiochemistry is not important here. Another case where regiochemistry is not relevant is when adding two different groups across a symmetrical alkane. This alkane is symmetrical because if you drew an imaginary line through this double bond, this alkane will be divided into two equal halves. Because of this symmetry, it doesn't matter if group A is attached to carbon 1 in this product or carbon 2 in this other product. Both products will be the same. For example, it doesn't matter which double bonded carbon the hydrogen and bromine atoms are attached to, the products are going to be the same. Now, let's discuss Markovnikov addition. This reaction is named after Markovnikov, the scientist who discovered Markovnikov's rule. According to Markovnikov's rule, if an unsymmetrical alkene reacts with a compound containing hydrogen that is bonded to an electronegative group, the reaction will be regioselective, and the hydrogen will be attached to the less substituted carbon of the alkene double bond, while the electronegative group X will be attached to the more substituted carbon of the alkene double bond. X could be bromine, chlorine, or even iodine. It could even be something different. Carbon 1 is less substituted because it has only one alkyl group, and carbon 2 is more substituted because it has more alkyl groups. For example, in this regioselective reaction, hydrogen will be attached to the less substituted carbon 1, and bromine will be attached to the more substituted carbon 2. Anti-Markovnikov addition. This reaction proceeds opposite to Markovnikov addition. The regiochemistry of this reaction is such that the hydrogen is attached to the more substituted carbon 2, while the electronegative group X is attached to the less substituted carbon 1. Now let's talk about stereochemistry. The stereochemistry of an addition product can be influenced by syn addition. Syn addition is when two groups are added to an alkene double bond from the same face, which could be from the top or from the bottom. Recall that an alkene has a trigonal planar geometry, which is another way of saying that something is flat. Because alkenes are flat, the reacting molecule could approach the alkene double bond from the top, and groups A and B can attach to the double bonded carbons from the top, leaving them with a stereochemistry where they would point upwards. Similarly, the molecule could also approach from the bottom, and groups A and B can attach to the double bonded carbons from the bottom, which will lead to a stereochemistry where both A and group points downwards. Stereochemistry could also be influenced by anti-addition. Anti-addition occurs when groups A and B attach to opposite faces of the double bond in the product. I'll be making a video soon on the hydrohalogenation of alkanes, where I'll solve problems and provide a deeper look into regiochemistry and stereochemistry. Please subscribe to this channel and turn on your notification button so you can get notifications when I post the new video. If you do enjoy this video, please like, share it with your friends, and leave a comment below. Thank you.